Okay. So out of solidarity to Peter, I will also talk I will also hold my presentation in English. You're welcome. So first, a few words from our sponsor. Maybe you noticed. So basically, here at Ericsson, we are big data. So if we look at how many data Twitter, Facebook, or even Visa works with, you can easily see that it's way less than network traffic. And here at Ericsson, we basically analyze a lot of network traffic and tweak the network. Basically, you can imagine how hard a task that is, having millions of parameters. Basically controlling this mess, this whole distributed mess. And here we are trying to make it manageable. So we are developing tools for network administrators to analyze the data and then plan or adjust their network based on the data. So that's all about the corporate stuff, and let's get to business. So the topic is Dagger 2. So and subtitle is Back to the DAG. So what the hell is a DAG? DAG is a directed acyclic graph to the math people. Maybe you've heard of it. I know for a fact that at ELTE and BM have you heard of it. I'm not sure about other universities. But basically what it means is we have a bunch of boxes, like Norby showed, and a bunch of lines between boxes. And these lines are directed from one box to another box. And a DAG is a network of these boxes where there is no path that points back to back to the originating box. So basically this is a DAG right here. You can see we have a bunch of, well, these are not boxes, but yeah, let's call them nodes. These, let's call them edges, directed edges. And we have a bunch of nodes that somehow point to other nodes. And basically we can use such DAGs to model a bunch of things. Such things are, for example, dependencies in a software, or dependencies between microservices, or family trees. For example, who was your father, grandfather? That is also a DAG. Or, for example, you can determine compile order with a DAG. If you have a bunch of components that depend on each other, you can determine what to compile first, then the dependence, then their dependence, etc. Also, DAGs are used for a bunch of Linux distributions. This is the dependency graph of the packages in Ubuntu. So basically, it's a huge mess. It's a little bit zoomed in, so you can see the nightmare in the middle. So basically this is called the node link diagram, by the way. And we somehow need to make this more understandable. And how can we make it more understandable? Maths. Basically, you can represent this also in a matrix form. It's called a structured dependency matrix, where you will see if if this graph is actually a DAG or not. And yeah, I found a nice little Stack Overflow question about this topic. It says, can someone show me a good dependency matrix looks like and specify why? And among the answers was this one. So yeah, it's bad. So basically you can see these are a bunch of let's call them modules or packages, Java packages. The same packages are in the same order on the top, and then the little dots are have the meaning that they depend on that component or not. And then you can see that dots are all over the place. So this is bad. And why it is bad? It's basically bad because this is a triangle. If we look at this matrix, if we have a triangular matrix, if we watch at the lower triangle, if any dot is above this line, that means that there's a cycle between the packages. So we want to avoid that top half. So basically it's, and also there's two buzzwords there, high coupling, low cohesion. What does that mean? I don't know, no, just joking. High coupling means that everyone depends on everyone. So you cannot easily take out a single part of the application and put it into another application, for example, because it has a bunch of dependencies that it cannot live without. Low cohesion means these dependencies to other parts are there because things that should belong together are not together. They are thrown all over the place. So let's look at a little better picture. Yeah, so this is more or less an optimal matrix. You can see nothing is above the line. This means no cycles in the dependency. If I want to take, for example, this component, I still need to take these out with it, but it's still better because I know that, for example, the top one I can compile without any problem, and even I know that this one I can compile. I have an order of components that I can compile where I can be sure that the previous dependencies are already compiled. So yeah, by the way, this is the graph of the Spring framework. Not to advocate, I'm actually advocating against Spring right now, but credit has to be given where credit is due. And so this is about the math part. Just so you know the picture that graphs are really important in this topic, also in microservices. I will get back to that a little bit later. So basically, this is the agenda. So I will show what exactly dependency injection is, how it relates to this whole DAG stuff. And then I will show this dagger, this micro framework of dependency injection. And then we will analyze when it should be used and when it should be avoided, because that's also a case. It depends when you use it. And then I will also talk about the complexity, if it's even worth it to talk about this, to use dependency injection at all. Okay, so a quick crash course. We have two interfaces, two service interfaces, and we want to consume services that implement these interfaces. And this is a consumer of the interfaces. You can see the services are stored in a field, a final field, and it calls in this doStuff method both services, concatenates them, returns the concatenated string. And the question is, how do I get the implementation? Because those are interfaces, and we need implementations to call these methods. Okay, so attempt one. Let's use a factory, because that's quite straightforward. Yeah, calling new service A implementation, I was thinking I won't put it in because that's just too simple. And so basically, what's the problem with this code? Anyone has any idea? Why wouldn't you use this? You still get implementations for both interfaces. What's the problem with this? Exactly. One of the main reasons is it's untestable. It can be testable, but you have to jump through a bunch of loops to make it testable. And also, through the service factory, you have a compile dependency on the implementation of the service. So you cannot really use this in, for example, on the client side. If I have the same class that uses services on the client side that has an implementation that calls a microservice, for example, and on the server side the same interface is implemented by a simple bean that does everything in the same JVM. So the problem is you still have a dependency on the exact implementation. It's only turned into a transitive dependency. So the next attempt, service locator. Service locator just pushes the problem to the runtime instead of compile time. You still have a dependency on the service locator class itself. The class is still problematic to test. Close to impossible to mock these interfaces in this scenario. A little nicer solution, but it's still the same, where you pass the class instead of calling a method called get service A or get service B. So it's cleaner, but it still has the same problem. So attempt 3. Let's just pass in the objects through the constructor, and that's it. Basically, this is dependency injection. Bye. So the issue with this, what's the issue with this? The issue with this is that the problem is not removed, it's just put elsewhere in the system. But still, the main advantage of this is that this class is much easier to test. It has no dependency at all on the implementation. So what we did is basically delegate the job of pairing the interface with the implementation to the one instantiating this object. And for example, it's your app, where you have the class, you instantiate the two services and pass it in the constructor, and then do the stuff you do. So what's the problem with this? Because right now it still looks a little fishy. It's not entirely clear in this because it's a very overly simplified example, but it starts to show that the problem with this is if service A implementation also has dependencies, and its dependencies have dependencies, we need to write a lot of news, and we don't really want to do that. What we just did is we put all of the complexity of instantiating all of the objects participating in our application into the main function, and we do not really want to do that. So basically, we need something that helps us with resolving this issue of having to write this news. Yeah, so basically, we can have factories, and these factories are not used in the object, but in the main class. And these factories will instantiate, and these factories will know the dependencies, but these kind of factories are better than the ones we saw earlier, and it's because the job of these classes is only to instantiate, where in the previous example, in the same class you saw the instantiation, so acquiring the implementation, and also the use. And if you know your computer science, then you know that there's this thing called solid principles, and S calls for what's S? Anybody know? So it's single responsibility principle. That means one class should do one thing, or one set of related things. Instantiating and using are two different things, so it shouldn't be in the same class. In this case, instantiation is the only job of the factory, so it's okay. But the issue is we still have to write the factories by hand. And that's where Dagger comes in. So basically, let's see a dagger. Let's see what dagger brings to the table. Little smiley face, that's the good part. It has a very small footprint, basically 17 kilobytes runtime dependency. By far the smallest dependency of all the dependency injection frameworks. That JUice comes in at about 500 kilobytes, Spring at several megabytes. So I think 17.1 kilobytes is quite nice. And that's just that's, for example, for Spring, that's just the one doing the dependency injection, not all the other aspect-oriented stuff and JDBC and etc. Just the dependency injection. So it does not use reflection at all. We'll see why that matters. That really matters, for example, at mobile applications. And it has very little overhead at startup. That is related to the reflection part. And what I failed to write here is another very important point, is that with Dagger, you validate your DAG, so your dependency graph of your classes at compile time, not runtime. So no more bean instantiation exception, as you know from Spring, because the compiler will say, hey, there is no bean bound to this interface. So at compile time, you will get the safety of having a complete DAG. It still doesn't eliminate bugs, but it does eliminate the bugs from wiring up your components. So the negative ports. Yeah, it needs some minimal effort to set up in an IDE. So an IDE does not instantly recognize. It needs to do something at compile time. You need, for example, in Eclipse, you need, if your project is a Maven project, you will need an annotation processing tool plugin that helps Eclipse recognize that on the class path there are annotation processor tools that will do some magic at compile time. Also, it's bleeding edge, so sorry about that, sysadmins and managers. You don't like that, but we do. So maybe it's hard to sell to the managers. Yeah, documentation is incomplete. That's usually the case with bleeding edge technology. I also had to go into the source code and find some features that were not documented properly. But I did find them pretty quickly because the code base is very small. So it's not huge stuff. And another negative is it's only dependency injection, nothing more, nothing less. So forget about aspect-oriented programming. Forget about what else is there? Yeah, forget about your JDBC template, for example. You still need to import that. But a word about aspect-oriented programming, it can still be done because there are things like AspectJ that can help out in that case. So it's really a micro framework for dependency injection because it only does dependency injection, nothing more. And that's good, I would have to say, because writing too many code is bad. So you want to use small amounts of code and don't write too much code. Okay, so how does the dependency injection work with a framework? First, you define binding. Oh, sorry. So first, you write your code. So write your constructors that define dependencies, and then from a dependency injection point of view, you need to define bindings. Under bindings, I mean you have to tell the framework, I want to use this specific implementation for this interface, because it needs to know somewhere what an interface has, who will implement an interface that you want to inject into your classes. And then after you've defined your bindings, you instantiate the injector, context, component. These names vary between dependency injection frameworks. So injector is Juice, context is Spring, component is Dagger. And then you request an instance from this injector and then call a method on it, obviously. So how do you define bindings? So one type of binding is just annotate the constructor where your dependencies are placed. So you can see in this example class, I have a dependency on the dependency interface. And then with the inject annotation, I say, hey, framework, I want to have an implementation of this interface. So this is called constructor injection. There are also two other types called field injection. This is much more concise, pretty cool, everything, but it's also not immutable. We like immutable things. And yeah, I don't really like it, but you will understand too if you start working with Dagger. And the third type is setter injection. Again, we don't really like this because setter injection promotes circular dependencies. So it's basically with setter injection you can simply, it's much more easy to do circular dependencies because you will instantiate example and you will instantiate a dependency that depends on example, and then you just call the setter that sets dependency, and then you have this nice little two arrows pointing in the different direction. So to be on the safe side, it's better not to use it and just use this one. And I also made a mistake. There should be a final there to make sure that it won't be overwritten during runtime. The object should be complete when it's instantiated, and final guarantees us that. Okay, so again, define bindings. So what's with the classes that first? What's with how do we define that? Yeah, I'm trying to find a phrase for this. How do you define what implementation a dependency should have? I made a huge mistake there because there should be a method name right there that says dependency. So basically, this is how you do it. You say this is the implementation, and this module will get the implementation, and then say if someone needs a dependency, then return this implementation. And then you annotate such a class with a module annotation, and then Dagger will recognize that this contains bindings. This kind of binding is also useful when your object needs to be instantiated in a custom way. So for example, if you use Jackson for JSON serialization, you might want to configure object mapper before injecting it into something else. So it would look like public object mapper, get object mapper, no parameters, and then in the body of the method you would instantiate object mapper and then set its properties and then return the configured object mapper. So it's this kind of binding also helps if you are using code that's not using dependency injection. So you can bind it into your code so it can be injected into your code. Yeah, and finally, and this is where Dagger is really different from Juice and Spring, is that you need, and it's not a class, it's an interface. I made another accident there. I accidentally an interface. So we need to define an interface annotated with component, and then specify each module containing bindings, and classes that are annotated with the inject, where the constructor is annotated with the inject annotation, is automatically recognized. So basically you have classes annotated with inject, and you have a bunch of modules that contain the code that binds implementation to interface or binds external libraries so that they can be injectable. And the big thing about this is this interface makes Dagger be able to build the object graph at compile time, because this says I want an implementation of example, use all the classes that are defined in the binding, and basically this shows Dagger that at compile time it needs to build a DAG that produces the example implementation based on that binding. So if you compare it with Spring doesn't have such an interface. You just tell to the application context that you want an instance of a class, and then it needs to dynamically see if it has the if it has a complete DAG for that class, and that all happens at runtime. So that the big constraint here is you need to specify all the classes that you directly want to access through your main function. I don't know if it's understandable yet, but I will show an example little pet project that maybe makes it more understandable. So, and this is how we will use it. At compile time, Dagger will generate an implementation for this my component interface, and the implementation is prefixed with Dagger. So in your main function, you just write Dagger my components dot create, and it will create your component basically. And yeah, so what we see here is two things. So it generates it at compile time. So basically what happens if the DAG for this component is incomplete? That means that this Dagger my component class won't be generated, so you will get a compile error here saying this class does not exist. And also you will get a compile error for this method, and the compile error will contain exactly what is missing. So it will say, for example, there was no binding specified for the specific interface, so it does not have an implementation for the interface to inject. And then you know that you forgot to define a binding between an interface implementation pair. So did I miss something? I don't think so. Okay, so this will create your instance, and this will instantiate. This will get the instance of this example class, and then you just use it. So it's quite similar in this regard to Spring. In Spring, you only have that part says application component, and then you say get bean and example.class, and that's where reflection comes in, because it's a reflective type. And then with juice, you have juice.create injector new module, and then you again have injector.get object, I think, and example.class. So it's basically the same. So it's not a huge difference in how you get instances. It's just that you have to strictly define what bean instance you will get from this component. But usually it's not such a huge deal, because you just need one class to bootstrap your entire application. Okay, so this is the Maven dependency you need to use Dagger. So the upper one is a runtime dependency. This contains a bunch of annotations and helper classes in 17 kilobytes again. And then the second one is a compiler extension. So it's an annotation processor, and you can see it's in scope provided, optional true, just to be safe that no one inherits it, because it's not too huge, but it's still under 1 megabyte. But you do not really want to have dependencies that you don't need at runtime. So when should it be used? So I talked a lot about reflection, that the other frameworks use reflection, and apparently for Android developers that's really bad, because Android is not standard Java. It's Google's own cross-compiled format called DAG, and Android's virtual machine doesn't really care about reflection performance. It has really bad performance even. Yeah, so it's bad. That's all you need to know. And with Android applications, that might be a problem, because when you start your application, you don't really want to wait 5 to 10 seconds just for your app to start. And with reflection, it might run up to half a minute. And same with applications in the cloud. I especially mention Google App Engine, because they have this silly practice that when your service is not used, it will be stopped. So if, for example, there's an hour of no users visiting your site, that means the first user that comes and polls your site's URL will trigger an application startup before doing this service call. And that means that if you have really slow startup, then and your website is not too popular, it won't become popular because it's slow, because it needs to start up fast. And again, another problem is this pay-by-the-hour billing scheme that a lot of cloud providers use. Again, with reflection, you probably consume more cycles at the beginning, and since it's startup, and if you, like for example the GitHub guys, deploy 50 times a day, that adds up. If you consume 1 second or 10 seconds, that means for 50 iterations, that's measurable money. And then there's also, I already talked about this runtime limitation that Android is really bad with reflection. So these are the cases when you should use this, and when it's better to use other frameworks. I mentioned aspect-oriented programming already. So basically, if you're heavily invested in Spring, you won't really like this. So I would say it's not worth migrating from Spring to Dagger. But if you have a pet project, or if you want to develop a microservice, it might be a good choice. And if you're developing Android native applications, there's no other choice. You're just basically you're fucking yourself if you're not using Dagger on Android, because there's no alternative. And again, same with the Java enterprise stack. It's sometimes better to stay there. And if you want simple transaction handling, it's again a problem, because with Dagger you need some external tools like AspectJ to achieve the same convenience. So, some usings. You ain't gonna need it. I don't know if you know this phrase. It comes up a lot in tech circles, meaning don't overcomplicate things. You're not going to need interfaces, because there's always just a single implementation. And again, same with dependency injection. Why are you using dependency injection? This is 200 lines of code and you're making 1000 lines of code from it, yeah, that's the case when you shouldn't use it. But as regular projects go, projects only grow, they do not shrink. And if you know for sure that this will be not a pet project, but it will go to production, it's safe to start with dependency injection. And again, this injecting interfaces versus concrete types, keep it simple. So it depends when you use interfaces, when you use concrete implementations. If you know that that you will have alternate implementations for that interface, it's safe to say you will have to program to the interface. But if you have a component of 4 to 5 classes or even 10, then it's not necessary to introduce 10 interfaces to those 10 classes, because you won't really have alternate implementation of that compare method, for example. Yeah, so now you might think, what's this? I thought you were going to talk about performance. Yeah, I just did. And sometimes trying out is simpler than talking about it. And since Dagger is really simple, I think I will show you an example, but I need my own computer for that. I will stop the recording of Norby.